I've drawn an arbitrary triangle right over here, and I've labeled the measures of the interior angles. The measure of this angle is x, this one's y, this one is z. And what I want to prove is that the sum of the measures of the interior angles of a triangle, that x plus y plus z, is equal to 180 degrees. And the way that I'm going to do it is using our knowledge of parallel lines or transversals of parallel lines and corresponding angles. And to do that, well, I'm going to extend each of these sides of the triangle, which right now are line segments, but extend them into lines. So this side down here, if I keep going on and on forever in the same directions, then now all of a sudden I have an orange line. And what I want to do is construct another line that is parallel to the orange line that goes through this vertex of the triangle right over here. And I can always do that. I can just start from this point and go in the same direction as this line, and I will never intersect. I'm not getting any closer or further away from that line. So I'm never going to intersect. I'm never going to intersect that line. So these two lines right over here are parallel. This is parallel to that. Now I'm going to go to the other two sides of my original triangle and extend them into lines. So I'm going to extend this one into a line. So do that as neatly as I can. So I'm going to extend that into a line. And you see that this is clearly a transversal of these two parallel lines. Now, if we have a transversal here, then that means, of two parallel lines, then we must have some corresponding angles. And we see that this angle is formed when the transversal intersects the bottom orange line. Well, what's the corresponding angle when the transversal intersects this top blue line? What's the angle on the top right of the intersection? Angle on the top right of the intersection must also be x. The other thing that pops out at you is there's another vertical angle with x, another angle that must be equivalent. On the opposite side of this intersection, you have this angle right over here. These two angles are vertical, so if this has measure x, then this one must have measure x as well. Let's do the same thing with the last side of the triangle that we have not extended into a line yet. So let's do that. So if we take this one, so we just keep going, so it becomes a line. So now it becomes a transversal of the two parallel lines, just like the magenta line did. And we say, hey, look, this angle y right over here, this angle is formed from the intersection of the transversal and the bottom parallel line. What angle does it correspond to up here? Well, this is kind of on the left side of the intersection. It corresponds to this angle right over here where the green line, the green transversal intersects the blue parallel line. Well, what angle is vertical to it? Well, this angle. So this is going to have angle, or it's going to have measure y as well. So now we're really at the home stretch of our proof, because we will see that the measure, we have this angle and this angle. This has measure angle x. This has measure z. They're both adjacent angles. If we take the two outer rays that form the angle, and we think about this angle right over here, what's this measure of this white angle right over there? What's going to be x plus z, x plus z, and that angle is supplementary to this angle right over here that has measure y. So the measure of the measure of this white angle, which is x plus z, plus the measure of this magenta angle, which is y, must be equal to 180 degrees because these two angles are supplementary. So the measure of the white angle, x plus z, plus the measure of the magenta angle, which is supplementary to the white angle, it must be equal to 180 degrees because they are supplementary. Well, we could just reorder this if we want to put it in alphabetical order, but we've just completed our proof. The measure of the interior angles of the triangle, x plus z plus y, we could write this as x plus y plus z if the lack of alphabetical order is making you uncomfortable. We could just rewrite this as x plus y plus z is equal to 180 degrees. And we are done. What I want to do now is just a series of problems that really make sure that we know what we're doing with with parallel lines and triangles and all the rest. And what we have right here is a fairly classic problem. And what I want to do is I want to figure out, just given the information here, so obviously I have a triangle here, I have another triangle over here. We were given some of the angles inside of these triangles. Given the information over here, I want to figure out what the measure of this angle is right over there. I need to figure out what that question mark is. And so you might want to give a go at it, just knowing what you know about the sums of the measures of the angles inside of a triangle, and maybe a little bit of what you know about supplementary angles. So you might want to pause it and give it a try yourself, and because I'm about to give you the solution. So the first thing you might say, and this is a general way to think about a lot of these problems where they give you some angles and you have to figure out some other angles based on sum of angles in a triangle equaling 180, or this one doesn't have parallel lines on it, but you might see some with parallel lines and supplementary lines and complementary lines, is to just fill in everything that you can figure out, and one way or another you'll probably be able to figure out what this question mark is. So the first thing that kind of pops out to me is we have one triangle right over here. We have this triangle on the left, and on this triangle on the left, we're given two of the angles. And if you have two of the angles in a triangle, you can always figure out the third angle, because they're going to add up to 180 degrees. So if you call that x, we know that x plus 50 plus 64 is going to be equal to 180 degrees. Or we could say x plus, what is this, 114. X plus 114 is equal to 180 degrees. We can subtract 114 from both sides of this equation, and we get x is equal to 180 minus 114. So 80 minus 14, 80 minus 10 would be 70, minus another 4 is 66. So x is 66 degrees. Now, if x is 66 degrees, I think you might find that there's another angle that's not too hard to figure out. So let me write it like this. So x is equal to x. Let me write x is equal to 66 degrees. Is equal to 66 degrees. Well, if we know this angle right over here, if we know the measure of this angle is 66 degrees, we know that that angle is supplementary with this angle right over here. Their outer sides form a straight angle, and they are adjacent. So if we call this angle right over here y, we know that y plus x is going to be equal to 180 degrees. And we know x is equal to 66 degrees. So this is 66. And so we can subtract 66 from both sides. And we get y is equal to, these cancel out, 180 minus 66 is 114. And that number might look a little familiar to you. Notice this 114 was the exact same sum of these two angles over here. And that's actually a general idea, and I'll do it on the side here just to prove it to you. If I have, let's say that these two angles, let's say that the measure of that angle is A, the measure of that angle is B. The measure of this angle we know is going to be 180 minus A minus B. That's this angle right over here. And then this angle, which is considered to be an exterior angle, so in this example, y is an exterior angle. In this example, that is our exterior angle. That is going to be supplementary to 180 minus a minus b. So this angle plus 180 minus a minus b is going to be equal to 180. So if you call this angle y, you would have y plus 180 minus a minus b is equal to 180. You can subtract 180 from both sides. You can add a plus b to both sides. So plus a plus b, running out of space on the right-hand side. And then you're left with, these cancel out. On the left-hand side, you're left with y. On the right-hand side is equal to a plus b. So this is just a general property. You can just reason it through yourself just with the sum of the measures of the angles inside of a triangle add up to 180 degrees, and then you have supplementary angles right over here. Or you could just say, look, if I have the exterior angles right over here, it's equal to the sum of the remote interior angles. That's just a little terminology you'd see there. So y is equal to a plus b. 114 degrees, we've already shown to ourselves, is equal to 64 plus 50 degrees. But anyway, regardless of how we do it, if we just reason it out step by step, or if we just knew this property from the get-go, if we know that y is equal to 114 degrees, and I like to reason it out every time just to make sure I'm not jumping to conclusions. So if y is 114 degrees, now we know this angle. We know we were given this angle at the beginning. Now we just have to figure out this third angle in this triangle. So if we call this z, if we call this question mark is equal to z, we know that z plus 114, we know that z plus 114 plus 31 is equal to 180 degrees. The sums of the measures of the angle inside of a triangle add up to 180 degrees. That's the only property we're using in this step. So we get z plus, what is this, 145? 145 is equal to 180. Did I do that right? We have a 15 and then a 30. Yep, 145 is equal to 180. Subtract 145 from both sides of this equation, and we are left with z is equal to 80 minus 45 is equal to 35. So z is equal to 35 degrees, and we are done. We're given a bunch of lines here that intersect in all different ways and form triangles. And what I want to do in this video, we've been given the measures of some of the angles, this angle, and that angle. And what we want to do in this video is figure out what the measure of this angle is. And we're going to call that measure x. And so I encourage you to pause the video right now and try it yourself. And then I'm going to give you the solution. So I'm assuming you've unpaused it and you've solved it, or you've given at least a good shot of it. So let's try to do it. And what's fun about these is there's multiple ways to solve these, and you kind of just have to keep figuring out what right over here. If this is 121 degrees, then you'd say, well, look, this angle right over here is supplementary to this angle right over there. So if this is 121 degrees, 121 degrees plus this green angle has to be equal to 180 degrees. So this is going to be 180 minus 121. Let's see, that's the same thing as 80 minus 21. 80 minus 20 would be 60, so that's going to be 59 degrees. So let me write that down. That's going to be 59 degrees. Now we see that we have two angles of a triangle. If you have two angles of a triangle, you can figure out the third angle because they need to add up to 180. Or you could say that this angle right over here, so we'll call that question mark, we know that 59 plus 29 plus question mark needs to be equal to 180 degrees. And if we subtract the 59 and the 29 from both sides, we get question mark is equal to 180 minus 59 minus 29 degrees. So that is going to be 180 minus 59 minus 29. Let's see, 180 minus 59, we already know is 121. And then 121 minus 29. So if you subtract just 20, you get 101. You subtract another 9, you get 92. So that's going to be equal to 92 degrees. This is equal to 92 degrees. Well, if this right here is equal to 92 degrees, this angle right here is vertical with that angle, so it is also going to be equal to 92 degrees. And now we're getting pretty close. We can zoom in on this triangle down here. Let me save some space here. So let me just say that that over there is also going to be 92 degrees. And at this triangle down here, we have two of the sides of the triangle. We just have to figure out the third. And actually, we don't even have to do much math here because we have one side that's, we have two of the angles of this triangle. We have to figure out the third angle. So over here, we have one angle that's 92, one angle is 29. The other one will be 180 minus 92 minus 29. And we don't even have to do any math here because it's essentially the exact same angles that we have in this triangle right over here. We have a 92 degree angle, we have a 29 degree angle, and the other one is 59 degrees. So in this case, it has to be also 59 degrees because over here they added up to 180, so over here they'll also add up to 180. So that will also get us to 59 degrees. We could just get that by taking 180, subtracting 29, subtracting 92. And then if this is 59 degrees, then this angle is also going to be 59 degrees because they are vertical angles. So we're done. X is equal to x is equal to 59 degrees. Now there's multiple ways that you could have reasoned through this problem. You could have immediately said, so let me start over actually. Maybe a faster way, but you wouldn't have been able to do as kind of as basic steps there. Is you said, look, this is an exterior angle right over here. It is equal to the sum of the remote interior angles. So 121 is going to be 29 plus this thing right over here. And we ended up doing that when I did it step by step before, but here we're just using kind of a few things that we know about triangles ahead of time to maybe skip a step or two. Although I like to do it the other way just so we make sure we don't do anything weird. So anyway, this is going to be 129 minus 29, which is going to be 92. And if this is 92, then this is also going to be 92. And then if this is x, then this is also going to be x. And you could say x plus 92 plus 29 is equal to 180 degrees. And you would say x plus 92 plus 29 is going to be 121 degrees. We already knew that before. And so that is going to equal 180 degrees. And so x is equal to 59. X is equal to 59 degrees. So there's a ton of ways that you could have thought about this problem.